Alright guys, we're back with another video. So I wanted to do a video on the build progress on the new red pocket bike, but I kind of got carried away and I just go into a fugue state when I start building and I don't think about anything else. So basically built everything at this point. We got the motor mounted, the motor plate down here, and then I ended up taking that pipe and cutting it and then welding it between the frame, and then welding the motor plate onto it, and then motor gets bolted to that. Let's see, so welded the motor on and then welded the motor controller on. Got a little scrap piece that's down there. Wow. Little scrap piece of metal, welded that on. It's bolted through there, and I got that aligned so that way I can align the top. Right there. So got another scrap piece of metal, drilled some holes through it, welded it to the frame. So that secures the motor controller inside of the frame. Come on, there we go. Then last thing I really needed to do was figure out a way to get the battery in. So as you can see, I did get the battery to fit inside the frame. It is a little bit taller in the frame than I wanted it to be. I was hoping it was going to be closer to the actual frame height where the tube is, but it's actually quite tall, but it's still roughly around the same size as that one. And I think that you'll still, when you're sitting on it, I still think you'll be able to lean over the battery like you can on this one, because this one you have a ton of room. When you lean forward, you don't even come close to touching the battery. So this one you might come closer to touching the battery, and I'll round these angle iron pieces, make sure they're not sharp or anything like that. So soften all that up. The battery tray is made of the same angle iron I used to make this battery tray. I had a 72-inch section, and so it took about half of it to make that battery tray. So I used the rest of it to make this battery tray, and it's basically just 4 of the angle irons cut in, I want to say 7-inch sections, and then I have them slightly V'd. They're closer at the bottom than they are at the top, so that way it makes it easier to get the battery in. It's about a ½ an inch difference, so it's not tremendous, but it's enough to where it slots in there easy. And it's not, since there's the foam that's covering it, the packaging foam that it was shipped with, it doesn't jiggle around too much. At least I don't think it will. I haven't ridden the bike yet. The next thing that I did was weld the key holder on. This actually came from a drive shaft, the remnants of the drive shaft that's right there on the motion sim, my seat mover motion sim. I had to shorten that drive shaft to get that to sit at the height I wanted, and so this little piece is the remnants of what I cut off of that, and it just so happened that the barrel of the key fit perfectly in there. So welded that on, jammed that in there, Now it has key start in roughly the same place as the small little silver one, the Cagliari. And my cigarette went out. Hold on, people. Hold on. There we go. Better. Okay. So I think that about covers everything I did. The battery tray, again, it's just the 4 angle irons. I have a piece of scrap iron that I use to weld at the bottom, so that way I could get the 4.5 inch distance there, and then it's 5 inches up at the top. It was a very tight fit. I measured that in the front of the frame, and the front of the frame kind of bows out from the back of the frame, you see. So measured in the front of the frame and tons of room, and then forgot that it narrows in the back of the frame, so I had to beat it in with a hammer. So it's not secured in any other way besides essentially press fit in there right now, but that'll be fine for a test ride to make sure everything's good, make sure I'm fine with that battery placement and I don't want to relocate it. So last part of the battery box, there's 2 pieces of iron, basically the same thickness and width. There's 2 pieces welded underneath to weld these 2 or the 4 pieces together essentially, and a tray for the bottom of the battery to sit on, so it's not resting on the motor or the controller or anything, and it can't teeter-totter now since those are all connected. So that's that battery tray. I feel it's very secure. Again, it's like 1/8 inch metal, so very secure, not going to bend. It'll hold the battery. And again, this one holds the battery perfectly fine without having a strap or anything on there. It did fall out once, but that was basically because someone full whiskey throttled and it went full 90 degrees and the battery fell out then. But as long as you don't do that, the battery is pretty secure in there. I am going to build a shell for it with fairings and everything, so it'll get secured. It's just hasn't been high on the list right now because it's very secure when I ride it. This one I feel is going to be even more secure because I think even if this went 90 degrees like this one did when the battery came out, this battery still wouldn't come out. I think it would have to go beyond 90 degrees for it to fall out this way, which is possible, but that again will get secured more than likely when I build fairings. So that brings us on to what needs to happen for this bike to be up and running. So currently I got most of the wiring done. Actually, I wanted to show you guys. Let me see if I can. I'll pull this battery out. There we go. There we go. All right. So if you ever run these my 1020 3000 watt motor kits from Kunrei, they come with these large silver motor controllers, and they're non-programmable. Meaning you can't get into it, you can't tell it anything. It comes how it comes, and that's it. That's all you get. So these motors are meant to be run in the opposite direction. They're meant to be flipped over, and I want to say that's how the Razors are run. I don't know if Razors run sprockets on this side. I want to say Razors run sprockets on the other side. So these are like straight out of the box, meant to be bolted up to a Razor, but since I'm bolting it up to what used to be gas-powered pocket bikes, they have sprockets on this side and brakes on the other side. So in order to flip this, I watched a couple videos and they said you just had to flip the motor polarity and then do the same with the Hall effect sensor. So the motor polarities are here. This side, these fat wires are to the controller, these thin wires are to the motor. and then this is the Hall effect sensor right here. So they said that if you just swap like blue and green like this, and then same over here, blue and green are swapped here, then that's all you would have to do for the sensor. So I tried that and I couldn't get it to work. I got it to, I want to say I got it to work. It didn't feel 100% correct, and reverse wouldn't work at all. And so I knew that the wiring wasn't correct. Did more research with Google AI basically, and it told me that these are asynchronous motors. And so instead of swapping blue and green on the Hall effect sensor, you would actually swap blue and yellow on the Hall effect sensor if you swapped blue and green on your power leads. So these are asynchronous motors, and so you don't mirror the swap of what you did here on your Hall effect sensor. You need to do an asynchronous swap, basically choose different wires to swap on here. I'm not 100% certain. I did what Google Chat told me to do, and it was correct. It reverse works. It feels like it has full power. That being said, I did disable reverse. I just disconnected it because there's a chance that when you turn, sometimes my finger would hit it, and I didn't want other people to accidentally be in reverse and not know it and then floor it. So plus reverse on a motorcycle is just weird anyway. So I just unplugged the reverse. So reverse does not work on here, but I wanted to show that. So I mimicked the same thing over here. The power wires are down in there, and I did the same thing. Blue and green are swapped there, and then on the Hall effect sensor, yellow and blue are swapped. So that should swap the polarity of this motor, so it'll rotate in the correct direction with it flopped around essentially from the way it wants to be. The next things to do is these, let's zoom me back in here. There we go. These power leads come with these little fittings that go inside of the power block, but the batteries come with XT90 connectors, and the chargers come with XT90 connectors. So instead of making a lead that goes from here to the power block and then powering that into the power block, I just cut these off and solder on an XT90 connector. This battery, two things about this battery. It actually says, it says there that it's a 30 amp max battery. So I'm really hoping that's not the case, because I did order a 50 amp hour, or not 50 amp hour, but a 50 amp BMS battery, a 3,600 watt essentially battery. So I have ridden this battery in this bike, and it felt like it was getting the same speed as the other battery that actually says 50 amps on it. Like this is that's the first battery I ordered. And so the seller of these batteries on Amazon basically cancels their listing after, I don't know, a couple of days or something. I'm not sure exactly the duration, but basically anytime I go back to look at it, the listing is canceled. So it feels like it's at 50 amps, so I'm not too worried about that. But it does have an XT90 connector on it that's like a different format than basically all of my other XT90 connectors. It won't really fit in the charger. It won't fit on this controller's XT90. Like, I can get it to work, I can shove it in there, but it doesn't fully seat like it's supposed to. So it's like minimal contact, which I believe is eating away. Where is it? There it is. Eating away at the brass on the end of that. So anyway, I'm gonna cut that off and then weld on a proper female XT90 connector on there. Solder on the XT90 male connectors on the power leads for the motor controller. And then I'm going to solder on an extra negative lead that's going to go down from here into the power block, and it'll just be a net negative, a ground for the power block. And then the buck converter that's over here and the 12-volt light, this will get wired up to this lead right here. This is the E-lock lead, and this is the one that only has power after you turn the key on. So I'm going to cut this and then splice this with the display that requires 72 volt and the buck converter that's 72 volt down to 12. Splice those together, and then the negative from the buck converter will go to the negative terminal on the power block. The positive out from the buck converter is going to go onto the power block, and then the headlight will get wired down onto the 12-volt power block, and then the negative on the power block, and then the negative for the display will also get wired onto the negative of the power block. So that way, that's essentially what I did over here. I just didn't use the power block. And what that means is if I ever want to expand, like get brake lights or blinkers or anything like that, if I ever want to expand off the 12-volt system, I'd have to disassemble the wiring situation I have down there. It won't be easy to add to it, is basically what I'm trying to get at. So I wanted to make it better on this system, and so if I use the power block for the 12-volt, then all I have to do is just crimp on one of those eyelet connectors and, you know, unbolt it, put the eyelet connector on and bolt it up, and then boom, I've got 12-volt power. So that's the way I'm going to do it on this one. Then speaking of the headlights, I've got to make a bracket like this bracket here that is thin and comes off enough to where the headlights and the brake handles don't hit it. So it'll come out super far, because these come out a bit. So yeah, the headlight's gonna have to come out pretty far to make sure that it doesn't interfere with those handlebars, but that's fine. And then mount the display. So yeah, either mount it to the tree or mount it to handlebars like I did that one. It won't have to be so tall because the battery is actually a lot shorter relative to the height of the tree on this bike than it is on this bike. Like this bike, the battery sits so much higher. It basically sits flush with the edge of the display here. So that is as far as we've got today. Ooh, I did not notice. I'm gonna have to tighten that. Yeah, that's as far as we got today. It's basically almost all the fabrication is done. The last two pieces that need to be fabricated are the light, the mount for the light, and then the mount for the display. And then the wiring needs to be finished up, and it's really just power resoldering those, which is going to be a pain in the butt to get them on the XT90 connectors. But once I do that, everything else is going to be pretty simple. The next thing after that, once I get everything done, it'll get tested, and if I like it, then I'm basically going to have to continue tearing this thing apart to get this rail, this fat chunk of metal, and that fat chunk of metal. And then I've got a length of pipe right there, the same length of pipe I used to build those swing arms, extended swing arms, and I will basically do the exact same thing for this. But like I said, this one's going to come off at a different angle. This one's going to be different and more complex than that one. That one was fairly straightforward. Still took me 2 days to build it, even longer to think about it in my head. But that one was the relatively straightforward one. This one, even though I know what I want to do, I don't know how difficult it's going to be and how much I need to strengthen and reinforce it. So It will be more complicated, but now that I have at least one bike with an extended swing arm, I won't be so manic to get this one actually built. But I wanted to give you guys another update. Sorry it didn't have more building in it, but that's kind of not what I do at this point, I guess. I just kind of show results. Anyway, you guys have fun. I'll talk to you later.